Hi everyone, myself Dr. M. Lakshmi Prasad, working as an associate professor in the Department of Data Science in Institute of Aeronautical Engineering, Hyderabad. In this video, I'm going to discuss about introduction to set theory. So you may also know that. So what is the set? So set is nothing but well-defined collection of distinct objects, and the objects in the set are called elements, or can able to called as members of the set. And normally these sets are going to be represented with capital letters and usually denoted the sets actually, and lowercase letters able to denote the element of the set. So set is nothing but a well-defined collection of objects, so which is going to be represented by capital letters, and the elements of the sets can be represented through lowercase letters. So they should be lowercase letters, and the set representation should be uppercase letters. So the elements of what are present in the set can able to called as members as well. So example, so collection of ovals in the word probability. Suppose if I'm going to consider this statement, so ovals, I'm going to create the set like, so ovals should be called as A, E, I, O, U. So A is there, and O, and I. So like this, I can able to create the set by considering the elements what are present in the string. Suppose if I'm going to find out what are the elements of the set or what are the elements of ovals in the word, then I can able to find out. So these are the ovals found in the set. Similarly, the collection of real numbers that is going to be satisfy the equation x squared y. So this is the equation they gave. So in this equation, so what I'm going to write, so I'm going to create a set of elements which is going to contain the elements that is going to satisfy the equation. So what is the element that is going to be satisfied? If I substitute 1, so 1 square minus 9 is not equal to 0, 2 and 3. So the element of the set is only the 3. So 3 means 3 square 9 minus 9, that is equal to 0. And similarly, the collection of 2-digit positive integers, so it should be divisible by 5. So for this one, so 2-digit positive integers, so it should be divisible by 5. So for this, I need a set 5, then 10, 15, 20, 25, like this. So these are the set of 2-digit positive numbers which are going to be divisible by 5. And similarly, the collection of football players in the National Football League. So this is also one of the example. And the collection of intelligent members of United States Congress. Like let it be A, B, C, D, E, like this. And we're going to see about what are the different types of sets. So for this first one is that the set with no elements able to call it as the empty set. So the set which is not going to contain any of the elements. So this set is able to call it as empty set. And it is also other synonym is that null set, and it should be denoted with the symbol pi. So example, the set of real numbers that is going to satisfy the equation. So see the example here, like x squared plus 1. So can you identify this set which is going to satisfy the equation? So if I'm going to substitute 0 itself, 0 square, not possible, 1, not possible, 2, 3, 4. So this is the set which is not containing any of the set. So that is going to be represented as pi. The set is not going to contain any kind of elements. And next one is that finite set and infinite set. So what is the finite set? So finite set is the set which is can be counted one. So example, set of 2 positive integers have 90 elements. An infinite set is the one which cannot be counted. So example, the set of integer multiples of the number 5. Okay. So the finite set and infinite set. So finite set is the one which is going to be counted one. Suppose if I'm going to have a set of values, so the number of elements that are present in the set is 5. So this should be called as a countable one. So infinite set means which cannot be counted. So like a is equal to up to so on infinity. So it is impossible to count the number of elements in the set. So like set of integer multiples of number 5. So like a is equal to integer multiples of 5. So 1, 5, and then 10, 15, 20, 25. It is not limited, right? And next one is that cardinality of the set. So cardinality of the set means which is going to be denoted by n of a. So that means the number of elements which is going to be present on the set will be treated as the cardinality of the set. So for the set A, so n of a, that should be the number of elements of set A. Similarly for infinite sets, number of elements of set A denoted as infinite. So here what I'm going to say that suppose I'm going to have 10, 20, 30, 40, 50. So I'm going to have set A. So n of a is going to be denoted as 5. Similarly, I'm going to consider another set A, B, C, D, E. So n of b, number of elements on the set 5. Like this, I can able to mention the number of elements of the set through presentation called n of a, but what we call it as the cardinality of the set. And next one is specifying a set. So how can I able to specify the set? Suppose if I'm going to have a list of elements explicitly, so like C is equal to A0I, and similarly if I want to list the elements implicitly, then I have to follow this convention. So sometimes it is possible the set is if the set is very small, then I can able to mention there should be the list of element explicitly. Suppose if I am going to have some more than 100 of element that is going to be present on the set, so at that time I can able to represent it as with the dotted lines. So what one able to call it as implicit representation, and this one what we call it as explicit representation. And use the set builder notation. That means there is some way notation is going to be considered here, like use the set and x such that x is equal to p by q, where p and q are the integer numbers and q equal to 0. So this is the set representation, what we call it as set builder notation. So instead of either of these two representations, so this is the another representation what can able to follow. So x says that x is equal to p by q, where p and q are should be the integers and q should not equal to 0. And next one is that universal set. So what is the universal set? Universal set is going to be represented with a denote a symbol called U, so which is going to include all elements under consideration in a particular discussion. So it depends on the context. So example, the set of Latin letters, set of natural numbers, and set of points in the line. So these and all will be treated as a universal set. So set of Latin numbers and set of natural numbers. Suppose I'm going to take natural numbers. So 0, 1, 2, 3, to so on. So this what I'm able to call that universal set. So the set of points on the line should also be treated as the universal set. So the set U includes all elements under consideration in a particular discussion. So it depends on the context. So the set of Latin letters and set of natural numbers and set of points on the line. Next one is membership relation. So what should be membership relation? So let A be the set and let X be some object, and notation is going to be represented as X belongs to A, and which is the meaning that X is the member of X or I can able to call the X is the element of A, or X is belongs to A. Okay, so this is the membership relation function. So it should be denoted by the symbol this one. So if I'm going to write, so X belongs to A, X is the member of A, I can able to call it as X is the element of A. And suppose if negated A, that means suppose A value does not belongs to A, so I can able to write that should be negated. So here I'm going to have a set like A, E, I, O, U. So I want to mention whether E belongs to oval set or not. I want to represent it. If E is present, so I can able to write it as E belongs to oval set. Suppose if I'm going to write X does not belongs to oval set. Okay, so does not belongs to or negated, what we're able to call it. So this is the relationship, membership relation we are going to be used in sets. And next one is that equality of sets. So here the two sets are going to be equal, then I can able to write it as A equal to B. So if they have the same elements, so otherwise I can able to write A not equal to B. So example, the set A of odd positive numbers is not equal to the set B of prime numbers. And set of odd integers between 4 and 8, then the set of prime numbers between 4 and 8. Equality of sets I want to represent it. Suppose A equal to 1, 2, 3, 4, 5. And B is also same 1, 2, 3, 4, 5. Then I can able to call it as A equal to B. In terms of cardinality also I can able to mention the number of elements in set A is 5 and number of elements in set B is 5. So that can also I can able to write A equal to B. So based on the cardinality and based on the number of elements, I can able to set whether A equal to B or not. Suppose if I'm going to have a set like A equal to 10, 30, 40, 50 and B equal to 1, 2, 3, 4 and 5. So at that time I have to mention, so then A is not equal to B. Okay, so in this example what I'm going to be specify is that, so if I'm going to have a set of odd integers, so over I'm taking, so between 4 and 8, so 5, 7, and set of prime numbers 5, 7. So I can able to say both sets are equal. And another kind of set what can able to call as subsets. So A is the subset of B, and if every element of A is an element of B, so then I can able to say that A is the subset of B. So how can able to denote that? We can able to denote with the symbol like this. So notation is A subset of B. That means some of the elements of A should also present in B. Suppose I am going to explain the example. Suppose A is equal to 10, 20, 30, 40, 50 and B equal to 10, 20, 30, 40, 50, 60, 78. So that means the elements whatever is there is also present in B also. So at the time I can able to say that A is the subset of B. And for each set A is subset of A itself, and each set B, so pi should also be belongs to set B. Then A is a proper set of B if and only if A is the set of subset of B. And next one, some of the operations on sets. So we are going to have union of sets. So how can you able to write? So we are going to have A union B. So in set builder form, how can you able to write it here is that, so X such that X belongs to A or X belongs to B. So here OR should be inclusive operator. Suppose if I'm going to have two sets A and set B, what I'm going to say that, so A union B. So A union B means, so X such that So X belongs to A or X belongs to B. So let's take an example. So A equal to 1, 2, 3, 4, 5 and B equal to 3, 4, 5, 6, 7. So what is A union B? The elements that belongs to A and belongs to B. So 1, 2, 3, 4, 5, 6, 7. So diagrammatically, if you want to represent also, you can able to represent. Let's take another example, A union B. So if it is all of real numbers, I'm going to take a characters. So like A, B, C, D, E. So then what is A union B here? So A union B should be 1, 2, 3, 4, 5. A, B, C, C, D, and so this should be the A union B operation. And next one is that intersection. So intersection means how can I able to write inside builder form. So A intersection B is going to be denoted by this symbol. So we should able to call it as exclusive. That means that X such that so X belongs to A and X belongs to B. So that means the element which is present in A should also be compulsory present in B. So then only I can able to say that A intersection B. So let's say take a set of positive integer numbers and B the set of prime positive integers. Okay. So if I'm going right, so the elements which are presented. So what is the common element that is present? Present in A intersection B 2. So that means A and B are the disjoint if and only if A intersection B equal to prime. So the elements which are not present in A and not present in B, then I can able to say that this should be the disjoint sets. So let's take an example like, so A equal to A, B, C, D, E and B is equal to A, B, E, C, E, F, G. So A intersection B. So I can able to write A intersection B means common elements. So A and C is present and E is present. So A, C, E. So A intersection B means the elements which are present both in A and B. So that can able to write A intersection B. Suppose if I'm going to have elements like A, B, C, D and B is equal to 1, 2, 3, 4. If I'm going to write A intersection B, then so these are the characters and these are numbers which are also not present in A and B as well. So I can able to write pi. No elements are going to be common here. So this A and B can able to call it as a disjoint sets. And next one is complements. So what should be the complement? So if A is the set of universal set, then complement of A is the set such that X belongs to universal set and then X does not belongs to A. So if I am going to have a set of universal set, then the complement of A is the set means so X belongs to mu but does not belongs to A. Okay. So if I'm going to write A intersection A complement is equal to pi and A union A complement is equal to mu. So these are able to call it as complement sets. So A is equal, so for example, A is equal to 1, 2, 3, 4 and 5. A complement is equal to 6, 7, 8, 9, 10. If I'm going to write A intersection A complement, so nothing is present. Right? Similarly, A union A complement is equal to mu. So this all the elements is going to be present in universal set. set of alphabets and then set of integers. So these are the formulas. And comes to the Venn diagrams. So Venn diagrams will also be represented. Suppose if I'm going to have a set A represented a disk inside the rectangular region called as a universal set. So this entire thing should be called as a universal set of all natural numbers, and A should be the set of numbers. So that means A is some part of this universal set. So here these are some of the possible diagrams, Venn diagrams we're going to have. So like A and B are the two sets, and this should be part what can able to call it as A intersection B. And similarly, if I'm going to mention all this, suppose I'm going to present A intersection B, how it will be. So this entire thing is able to call it as A union B. So the elements which are present in both A and B considered as A union B. And if I'm going to take, so these are the elements and these are some other elements. That means B is the subset of A. So the elements which are present in A should also present in B also. Then I can able to, those things should be the common, right? So that should be the B should be the subset of A. So like this we can able to construct the different types of diagrams also by make use of this Venn diagram. And complement of the set. So complement of the set means, so all the elements of set A, so rest of that is going to be available in A complement. Okay, so how can able to show in the form of diagram means like this. So this is the elements so which are not present in that A complement. Okay, so like this we are going to be represent the Venn diagram for A complement. See, this is the set of elements and these are the set of elements. Let's take an example. So A is equal to 1, 2, 3, 4, 5. B is equal to 6, 7, 8. 1, 2, 3. So I can able to construct this Venn diagram. So 1, 2, 3, 4, 5, 6, 7, 8. So A union B means so all the elements of the set. So 1, 2, 3, 4, 5, 6. So all these elements is going to be present in the set A union B. Similarly, how can I able to construct the A intersection B? Suppose if I'm going to have a set 1, 2, 3, 4, 5 and B is equal to 1, 2, 3, 7, 8, 9. So that means A is going to have the values 1, 2, 3, 4, 5. And here also 1, 2, 3, 7, 8, 9. So what are the elements that are common here? 1, 2, 3. And here also same. And these are the two different values. So the elements which are present, which are common in set A as well as in set B. So then I can able to call it as intersection part of the set. And sets formed by the two sets. Suppose we're going to have a sets like R1. So A intersection B complement. So the region R1 should be that. It should be the equation of A intersection B complement. And what is this R2? A intersection B. So just now what I said. So these are the elements which are present common in both set A and set B. And what is this region R3? So this region A complement intersection B. So these are the elements which are present not in A. And R4 means A intersection B complement. So this is the region what we're able to call it as A intersection B complement. So like this we can able to construct the Venn diagrams. And next one we are going to have some of the basic counting rules. So that means if A and B are the finite sets, then how are we going to calculate the number of elements of A union B? So the equation is that n of A plus n of B minus n of A intersection B. So if I'm going to have a set like 1, 2, 3, 4 and B is equal to 4, 5, 6. So n of A, the cardinality of A union B, how can I able to write? So I can able to write, so 1, 2, 3, 4. So that means what should be the n of A? So how many number of elements? 4 and n of B 3. So according to the equation, so n of A is 4 plus 3. What should be the A intersection B? So which are common in both? 4, only 4. So 1. So minus 1. So what should be totally? It should be 6. Okay. So like this, we are going to calculate the cardinality of A intersection B. So similarly, if I want to find what should be the equation for A intersection B complement, so for this I have to write cardinality of A minus n of A intersection B. So like this, we are going to have some of the equations. Suppose if I'm going to have A intersection B equal to, how can I able to write? So n of A union B. So n of A plus n of B minus n of A union B. I can able to get the A intersection B. So similarly, how can I able to get through n of A intersection B complement? Suppose if I want to find number of elements is equal to n of A is equal to n of A intersection B complement minus n of A intersection B plus is going to be obtained. So based on these rules, I can able to find out the number of elements in the set. So this should be about sets. So set is nothing but a collection of distinct objects, and the objects in the set what can able to call it as members of the set or elements of the set. So normally are going to be denoted with capital letters, and the elements of the set is going to be represented to lower elements. So here these are some of the examples what I discussed, and we are going to have different types of sets called empty set. So the set is not going to have any kind of elements, should be treated as a null set or empty set, and it should be denoted by the symbol pi. And finite means we can able to count the number of elements, whereas in infinite means we should not count that numbers. And cardinality of the set means where we can able to be find out the number of elements present in that one. And we can also specify different types of rotations like set builder notation and membership notation like this. And universal set is the common one which is going to be include all the elements under consideration, and this should be the membership relation, whether the element belongs to set or not. I want to represent it. And equality of the sets, that means if the two sets are going to be equal, then I can able to write A equal to B, otherwise I can able to write A is not equal to B. And subset, so subset is going to be denoted by the symbol like this. So that means some part of the elements belongs to some part of B. And union, so other operations what can able to call it union. So union means all the elements that are common in both A and B, and intersection means that should be the common element that are present in A and B. And complement should be that it is going to be used when I'm going to consider this universal set. and we're going is how to construct these Venn diagrams by considering sets. So these are different representations of the set like union, intersection, complement, and disjoint like the subset. And so complement of the set look like this, and union of the sets which is common, and intersection part, and then the set forms by the different sets. So just now I shown how those regions is going to specify the values and what are the equations that have to be followed. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.